So right now this video is being made to kind of augment the instruction provided in section 2.2, particularly with a focus on how we get rid of fractions when we are working on solving equations, since I provided some instructions on solving equations in class last week. So we have here the original problem, 2 over 9x equals 2 over 3. Now, if there are those of you out there who are familiar with solving equations in a more traditional way and getting rid of the fractions a more traditional way, this method is going to look a little different than that. What I'm going to do instead is, instead of trying to find the least common denominator for all this and then multiplying that through, I'm just going to multiply the entire thing by 9 times 3 over 1. And it makes the work for this a little more concise and neat. It makes the reduction of the fractions and canceling very simple. So what I'm going to do now is I'm going to go ahead and I'm going to distribute this through to both of the parts or the terms in the equation, both on the left and right hand side of the equal sign. So the first part is going to be taking 9 times 3 over 1 and multiplying it by 2 over 9ths. What will happen is that this 9 is going to reduce this 9, leaving me with 3 times 2. So if this 9 and this 9 reduce, 3 times 2 give me 6x. So I'm going to have 6x here. I'll bring down the equal sign. If I look at this part here, then what's going to happen is that this 3 is going to cancel this 3, leaving me with 9, and therefore 9 times 2 will give me 18. What we don't have in this problem anymore are fractions. And since I have 6x is equal to 18, I'm going to go ahead, I'm going to bring this work up here. And when I divide both sides by 6, I simply get x is equal to 3. And that's going to be the answer to question 5 from that portion of the work. Let's go ahead and take a look at how that applies to question 6 now. So let me go ahead and write out question 6. This is going to be k divided by 13 equals 0. Now, if some people out there may recognize that, hey, if I just let k be equal to 0, 0 divided by 13 will equal 0. Again, I'm not focusing on that particular part of it. I simply want to work on getting rid of the fractions in the equation. So how am I going to do that? I'm going to multiply everything by 13 over 1. When I multiply this side, the 13s cancel automatically, and that's just going to give me k. If I multiply 13 by 0, there's nothing to reduce the 13 with here, but 13 times 0, that's just going to go ahead and give me 0. And that question is now going to be solved. We're going to go ahead now, and by the way, if you ever want to try these problems on your own before you see the solutions worked out, just feel free to pause the video and then see what you can do from there. I'm going to look at question 9 now, which is going to be x divided by 5 try this again, x divided by 5 plus 4 equals negative 4. Now, as we discussed from class, we could move that 4 to the opposite side, kind of simplify that in the beginning, but I know for a number of you, having the fraction there still makes people uncomfortable. So I'm just going to go ahead and multiply everything by 5 over 1 before we make any moves. The 5's reduce here, and then since there's nothing left on top, that's just going to give me x here. Next, I'm going to have 5 times 4. There's something to cancel this 5 with here, so 5 times 4 is going to give me 20, and then equal sign, and then 5 times negative 4, there's nothing to cancel the 5 with here, so that stays. So 5 times negative 4 is negative 20. So my current equation is x plus 20 equals negative 20. So based on what we learned in class, we can write this now as x equals negative 20. I'm going to bring this 20 over here with this is minus 20. So that's going to give me x is equal to negative 40. And that's going to be the answer for equation number 9. Taking a look now at the work in problem number 10, we have 6/7 x equals 24. So what can we do in this problem? We're just going to go ahead and multiply everything through by 7 over 1. We get the 7 from the number in the denominator. So what we're going to do now is just look at this. 7 divided by 7, that's going to equal 1. So these will cancel. Just leave me with 6x. 7 over 1 times 24. Well, there's nothing to cancel the 7 with, so it takes 7 times 24, and that's going to give me 168. I wouldn't necessarily expect people out there to be able to do that calculation in their head, so get a calculator in order to carry that out. So if I take 6x equals 168 and then divide both sides by 6, I'm going to get x is equal to 28. And there's going to be my final answer for that problem there. But what's the first helpful step? Getting rid of the fractions in the problem. We're going to just take a look now and get away from getting rid of the fractions at the moment, but we'll pick that up in section 2.3 most likely. We're going to take a look at the last two problems that are included in your homework to give you some assistance with this. A 2-foot board is cut into 2 pieces. If one piece is x long, express the other length in terms of x. All right, so let's go ahead and take a look at this from a one standpoint. So if, let's say, for example, we have a board that's 10 feet long, and we cut it one piece into 7 feet, what would the length of the other piece be? We would say, okay, well, that's not bad. That's just going to be, well, we won't talk about that yet, okay? So let's say there are 2 pieces. We have the first piece and the second piece. The first piece is going to be 7 feet. Most people will know that that second piece is going to be 3 feet. But how do you get 3 feet? You would take 10, which is the total length of the board, minus the length of the first piece, which is 7, to get 3. So what are we doing in this case here? We're taking the length of a board that we know is 2 feet. So we're going to put that here. So if we have the length of a board and that's 2 feet, okay, and we know this is x, how do we write this out? Well, the first board is going to be x, just like the 7 is here. Here, we don't know what the length of x is, so we can't give this a number. What we can say is, if we do know that the whole length is 2, and that the other piece is x, just like we got 10 minus 7, we can write this as 2 minus x. So this is going to be 2 minus x. So I'll say that one more time. Just like if we know the length of the entire first board is 10, and we know this length is 7, we would take 10 minus 7 to get this length, which would be 3. But since we don't know what this length is, we can't combine like terms, we know we would have to get this length, we'd have to take the whole board minus that part of it, or 10 minus 7. In this case, that would be 2 minus x, and that's going to give us the length of the other board. And the other problem here, last question, it says to write an algebraic expression described. Recall that 2 angles are complementary if their sum is 90. If one angle measures d, express the measure of the angle of the complement in terms of d. All right, so let's just take a look at this from a numerical perspective first. So let's say I know 2 angles add to 90 degrees. If I know that one of those angles is 60, a lot of people would be able to, in their head, they'd be able to say, well, if that's 60, well, that's going to be equal to 30. But what's another way, how would we calculate 30 degrees? We would take, in this case, 90 minus 60 to get 30 degrees. But in this case, if we're looking at 2 angles that measure 90, and the other one's going to be x, then we, instead of 90 minus 60, like we have 90 minus this, it's going to be 90 minus x. So the measure of this angle here is going to be 90 minus x. So that's just a brief video on some of the stuff that we'll be covering in section 2.2. I encourage people to watch that and to look at the other notes and what they have to say online. And we'll do a video for 2.3 next.